Yeah. Hey, good morning, Skylar. Good morning and good afternoon, everybody. I guess from Live Vantage Zoom Studios. It's a pleasure to be here. A lot of people have commented on my beard. I think I've decided. I see I'm a huge hockey fan. I don't know if there's any other hockey fans out there or maybe Canadians. But it's tradition in playoff hockey that you don't shave your beard until the finals are decided. So I think with this whole coronavirus nonsense going on, this is kind of my coronavirus beard, and I'm not going to shave until this nonsense is over. Um, but like Skylar said, I want to jump in. I want to talk about products. But really what I want to talk about is nutrigenomics. Okay. But I want to couch this conversation of nutrigenomics around disruptive innovation. So let's first talk a little bit about what is disruptive innovation. Well, if you look at the definition of what exactly is disruptive innovation, it's an innovative and creative approach to introducing something to the marketplace that eventually disrupts an existing market, displacing established market-leading companies, usually driving them completely out of business, and then their products become the overall market leaders. So what would some examples be? Well, some examples might be, let's think about,
Ryan,
I'm sorry?
sorry to interrupt.
No, please.
Are you by chance trying to share your screen?
Yeah, is it not?
It is not sharing at this moment, but just want to give you a heads up. We just
Screen, and then you got to do the second step.
Oh, no, thank you guys. Thank you, Carrie.
yeah, there we go.
You got it there?
Yeah, that's a
Alrighty.
PowerPoint. I mean, I might have to steal that from you sometime.
So that's that whole definition of disruptive innovation, like I mentioned. It's really creating a product that's just so new to the marketplace that it's going to disrupt the entire market. So let's walk through maybe a couple of examples. I mean, how many people drive a horse and buggy anymore? How do you think horse and buggy sales are doing these days? Henry Ford didn't invent the automobile. What he invented was the process to be able to mass produce cars so that everybody could eventually own and drive a car. And we might even be on the precipice of another disruptive technology, even in the automobile industry. And that could be electric cars. Who knows? Maybe in the next 10 years, 15 years, 20 years, we might all just be driving electric cars. Well, what about encyclopedias? Is anybody old enough like me to remember those door-to-door salesmen that would come around selling you encyclopedias? Well, how do you think encyclopedia sellers are doing these days with the invention of the internet, and then specifically Wikipedia? How many of you are looking up things encyclopedias anymore, and rather you just go to Wikipedia? How about the film industry? There's a funny story about Kodak. Kodak was originally approached in the 1970s for digital photography. And then do you know what their answer was? Business of film photography. Well, Kodak has since gone out of business because of digital photography, because they weren't able to embrace an innovation in their marketplace. How about phones? I mean, much less those old push button or rotary phones we used to have. Think about how far even cellular technology has gone, from cellular phones. But think about the iPhone. My brother and I like to joke around that you can hold the whole sum of human knowledge in your hand because of now an iPhone or other smartphones. You have access to the internet. You can literally look up anything that you want. Think about this whole gig economy. Think about what Uber and Airbnb have done for the taxi and hotel industry. But I think we can also throw direct selling in there. I mean, think about the current economic environment. Do you not think that direct selling might completely disrupt how business is being done right now? Think about what we're even doing today. I mean, back in the day, we used to have to take pictures of the slides that we wanted to present and then load them into a little film carousel. Now, you have to be probably really old to remember those types of presentations. If we were fortunate enough to all be in the same room, I'd be giving this presentation digitally. But now look what's happening with all of us on Zoom. So now we can give these same presentations, even reach more people digitally because of all this disruptive innovation that's happening around the digital era. But now let's kind of dovetail back into nutrition. Has there been any innovation in nutrition in, who knows, the last 200, 100 years? Well, let's talk about that. So think to yourselves, how long have we known about all of the essential nutrients that our bodies have needed to run optimally? And to ask that question, does anybody know when the last essential vitamins were discovered? And I'll talk about maybe the last three that were discovered. So vitamin K was discovered in 1939. Folate was discovered in 1941. And the last essential vitamin to be discovered was vitamin B12 in 1948. So think about how long ago that actually was. We have literally known for the last 70 or 80 years everything the human body needs to function optimally. I'd argue that there really hasn't been any sort of innovation in nutrition in that last 70 or 80 years, maybe until now. How about nutrigenomics? Right? Nutrigenomics is an amazing innovation that has happened in the marketplace around nutrition in just the last 10 or 15 years. And so we really are in the middle of this nutrigenomic revolution. So if you want to know what nutrigenomics is simply, you can kind of break the word down into its parts. It's nutrigenomics. So that stands for nutrition and genomics. And that's really nothing more than how nutrition is activating genes, and then how genes in turn are affecting those nutrients that we're consuming. But what I really want to talk about today is really how that process is working. And so again, to put it as simply as I can, it's simply nutrition working through cell signal. This conversation about nutrigenomics, I think we need to have a conversation about cellular signaling and then ultimately gene activation. So let's break this down into its parts. So do we need a brain to be intelligent? I want to get you thinking about something here for a second. Do we need a brain to be intelligent? Is it the 3-pound organ on top of our heads that really differentiates us from the rest of the animal, plant, and even lower organisms out there? Well, let's talk about this. When you break down intelligence into its just simple definition, intelligence is the ability to learn or understand things. This is how I think most of us think about what intelligence is. It's that kid that's really good in school, that kid that gets good grades, that kid that's quote unquote really, really book smart. But what's so intriguing to me is this second part of the definition. Intelligence is also the ability to deal with new or difficult situations. Okay, so think about that just for a second. So think about everything that you're doing here today. Sitting, breathing. You thinking about the blood flowing through your blood vessels? Are you thinking about all those nerve impulses that are going through your body? Are you thinking about digesting your breakfast or lunch right now? Exercising today? Are you thinking about your bones and your muscles being completely remodeled, repaired, and built back even stronger? I don't think so. These things are happening outside of our brain. But let's look how this is happening inside of other lower organisms. Take bacteria, for example. Pound for pound, bacteria are the most successful organisms on the face of this earth. If we took all of the bacteria that live on Earth and put it on one side of a scale, and you put all the humans on the face of this earth on the other side of the scale, bacteria would far outweigh all the human mass that's on the face of this earth. Now think about that. The most successful organism, pound for pound on the face of this earth, is a single cell and clearly doesn't have a brain. How about plants? When you put a seed in the ground, how do those roots know to grow down and those leaves know to grow up? they clearly also don't have a brain. Sunflowers, they follow the sun throughout the course of a day. And then at night, they even reset themselves so they're facing the sunrise the next morning. Insects are considered the most biodiverse organisms on Earth. Now, think about that. There are currently over 1 million different species of insects that have been identified. It's even estimated that there's over 4 million different types of insects on the face of this earth. They've been successful, and they only have a very primitive brain at best. Fish, how do they know how to swim in schools for safety or for travel? How do dogs know how to fetch? Think about other mammals. Most mammals, within minutes, if not hours after they're born, can actually stand up and walk around. How do they know how to do that? Does that make them more intelligent than we are? And again, relative to their body weight, they have very small brains, but yet they're able to do an incredibly complex behavior. And then think about ourselves again. I think we've all probably cut our fingers, but what happens to that little cut over time? Doesn't it eventually heal and literally become as good as new again? How does the skin know how to do that? And I think something that we don't appreciate is that that wound healing process is a highly coordinated process that involves a number of different cells inside of our body. It involves the immune system to remove all the damaged cells that to repair that tissue ultimately. But when that happens, are we thinking about it, or does it just happen? So for all of this highly intelligent, adaptive behavior, do we truly need a brain to be intelligent? I think the answer is clearly no, that there is very intelligent behavior that's happening outside of our big, complex brains. But if you had to put a word on this, what word would you put on it? What did everything have in common? Is it luck, skill, adaptation? What I would call it, if you were to ask me, is instinct. These things are just happening, right? But what is instinct? And more importantly, where does instinct live inside of ourselves? Well, if you ask me, I say that this instinct lives inside of our DNA and more specifically, our genes. So maybe just to clear up a little bit of terminology, inside of almost every single cell in our body, inside of the nucleus, inside of these cells, we have our DNA. Our DNA is broken down into smaller little pieces that we call genes. And genes are nothing more than the instructions for the cells to make something. What that usually is a protein or an enzyme. Okay? So this instinct is living inside of our DNA and genes. The analogy that I like to use is like this blueprint. So is there a lot of information on this sheet of actually build the house? No, a piece of paper can't swing a hammer. It can't pour concrete. It takes a very highly skilled worker to be able to read that blueprint and then ultimately be able to direct a team of workers to ultimately build that house. Okay? So who or what are the workers inside of that cell? Who's actually doing the work? It's proteins. And more specifically, it's enzymes. And I like to think of enzymes as being like these little machines inside of our cells that are actually doing the work. They're making the stuff our cells and the rest of our tissues need to live successfully. Okay, so now we know where the information's coming from. We know who the workers are, but who is the boss? Who's the foreman of the cell directing all of those workers? Well, it turns out it's cell signaling. And more specifically, we should say it's coordinated cellular signaling. And it's literally as simple as initiating something with A tells B tells C tells D, and then something happens. Okay. So this is obviously an incredibly complex chart of cellular signaling, but as a molecular biologist, this is exactly the kind of map that we would look at when we're trying to figure out how a cell signaling pathway or signal is actually making it through the cell. So it's initiated at A tells B tells C tells D, and then physiological response. That's cell signaling, all in a nutshell. So if that's how cell signaling is working, what's actually kicking off the cell signaling? It's receptors, okay? So think of receptors as being these little sensor molecules that live on and inside of our cells. These sensor molecules are waiting for the right stimulus or signaling molecule to come around to initiate it, right? A tells B tells C, and then something happens. Another analogy I like for cell signaling is one of a lock and key. So it turns out with these receptors and other signaling molecules, there's highly coordinated specificity that happens with these signaling molecules and the receptors. So think of a lock and a key. Think about the key that opens the front door to your house. The key that opens the front door to your house won't open the front door to my house, just like my key to my front door won't open the front doors to your houses. There's this specificity that happens between the signaling molecules or the key and the actual receptor or sensing molecule or the lock. So once you literally unlock these receptors, and if you look at the top of that complex chart again, it actually says receptor up there. So those little orange things are the receptors waiting for that signaling molecule or the key to come along, right? So look at those gray circles and triangles, the signaling molecules. They come, they unlock the receptor. A gets activated, then tells B tells C tells D, and then some physiological response happens inside of our cells. But another analogy I like is one of dominoes, even simpler. So think about when you've seen these huge domino exhibitions set up. They'll knock over the dominoes, and then there tends to be some huge grand finale that happens at the end. This is exactly what's happening with cell signaling. These dominoes get knocked over, and then there's some physiological consequence or grand finale that's happening inside of the cells. So I'm going to show you a little video here to kind of illustrate that. But just on this still image of this dominoes, can you see all of the aspects of cellular signaling? Where would the receptor be? It would be that first domino. Where would that signaling molecule be? It would be that man's finger. And then A is going to tell B, B is going to tell C, and then something happens. So watch, one small little input is going to have a massive consequence. One domino is going to knock over ultimately every single domino you can see on the screen. It's amazing. And this is exactly the power of cell signaling. There can also be signal amplification. So a tiny little input can have massive consequences to the cell. And I can give you maybe a couple of real world examples. So think about a bodybuilder. Most bodybuilders out there have to cheat to compete, especially on that professional level. They will inject testosterone into their muscles to literally put on massive and unphysiological amounts of muscle. A tiny input can have massive consequences. Think about women. We can give them a tiny little birth control pill, and we can completely remodel their reproductive physiology. A tiny input can have massive consequences to the cell, and this is exactly the power of cellular signaling. So here's another short video around dominoes that illustrates that concept of signal amplification and the power that can happen. So watch when he knocks over that first tiny domino over that last domino, or between 50 kilos or around 100 pounds. A tiny input can have massive consequences. This is what's coordinating cellular function. Cell signaling is literally what's making everything happen inside of the cell in a coordinated way. So what's the purpose then of these cell signaling pathways? Well, come back and think about that original definition of intelligence. Allowing the cell to react and respond to their internal and even external environment. So it literally doesn't matter which cell signaling pathway I show you, this one, this one, this one, etc. They're all working in the same way. There's a receptor that's sensing the surrounding environment. A tells B, B tells C, C tells D, and then something ultimately happens, okay? So how does this feed into nutrigenomics? Well, with the sequencing of the human genome, this really opened up the doors for genetic studies. So sometime around 2003, 2004, 2005, there really started to be a lot of work of the role that nutrition was playing, especially centered around our genes. For me, when it comes to nutrigenomics, this here is the seminal work that really illustrated the power that nutrition can have on our bodies. So I think most of us out there have heard that eating chocolate, and specifically that nasty, bitter, sour, dark chocolate, actually has some great health benefits. And specifically, that dark chocolate and the compounds found in dark chocolate have great cardiovascular health benefits. So the researchers in this study wanted to figure out exactly what was going on. But when they started down the road of these studies, it turns out they got very perplexed. So as they started teasing the various compounds of chocolate out, what they found is that some of these compounds were present in incredibly low concentrations. More than that, when they gave those compounds back to humans directly, they found that they were very poorly absorbed. Right? More than that, those compounds were metabolized and excreted incredibly quickly. Okay? So how could compounds that are present in such low concentrations in nature, that are poorly absorbed, that get metabolized and excreted incredibly quickly, how could they be having any sort of health benefit? Well, in some follow-up studies, what they ultimately found was that these compounds from chocolate weren't actually acting in traditional nutrient fashion. They weren't diffusing into the cell and having some sort of direct effect. They were having these indirect effects by binding to a receptor or a sensor molecule, and then look what it says at the bottom of that screen: activating cell signaling pathways. And more than that, they were actually able to figure out the specific enzyme that was activated that led to those improvements in cardiovascular health. How amazing is that? So there it is. That's what nutrigenomics is: utilizing nutrition to activate cell signaling pathways to turn on genes. But what's so interesting is what these genes have been called. So they kind of lump all of these genes together, and they call them maybe adaptive genes. They call them anti-stress genes. They call them survival genes. So literally, we're trying to utilize nutrition to activate cell signaling to turn on these very important mechanisms for human health. And this is exactly where we're at. We're in the middle of this nutrigenomics revolution, and we can even argue that LifeVantage kicked off this nutrigenomics revolution in the nutritional industry. This is why I'm proud to represent this company, because we have been literally from our start at the forefront of disruptive innovation in nutrition. This is also why we love the tagline: flip the switch, feel better, and do more. So think about that for a second. Flipping the switches, what are we talking about? We're talking about flipping those switches in cell signaling. We're talking about flipping those switches on those genes that are so important for human health. And then as a result, we can feel better and we can do more. And so with that, I'd like to hand it back to Skylar and just say thank you everyone for tuning in this morning.